All right, let's talk about one of the most important tools in all of tech, Git. We're going to treat it like a time machine for code, because honestly, that's exactly what it is. It lets developers jump back in time, try out new ideas without breaking anything, and build all the software that runs our world. So let's dive in. So let's start with a big question. Have you ever really thought about a huge project like Windows or Linux? You've got literally thousands of people all over the world writing millions and millions of lines of code. How on earth does that not just completely collapse into a mess? Because, without the right system, it would be total chaos. Just picture a group project, maybe 5 of you, all trying to edit the same document at the exact same time. Somebody deletes your best paragraph by accident, someone else adds something that totally breaks the flow. It's a nightmare. Well, that's the problem developers face, just on an absolutely massive scale. So, what's the secret? How do they manage this chaos? Well, they use a system that's basically, you guessed it, a time machine for their code. The official term for this idea is version control. And a version control system, or VCS, does pretty much what it says on the tin. It's a system that just keeps a log of every single change you make to a project. Every line you add, every typo you fix, every file you delete, it's all recorded. This creates a complete history, so you can rewind to any specific point in time you want. Probably the best way to think about it is like saving your progress in a video game, right? You never want to start the whole game over just because you messed up on one level. You rely on those save points, those checkpoints. Version control is exactly that, but for building software. And the most famous, most widely used version control system out there is called Git. Now, Git is smart. It doesn't just save the one file you changed. Instead, it takes a snapshot of the entire project at that moment. And by stringing all these snapshots together, it builds this incredible, detailed timeline of everything that's ever happened.
Okay, so how does Git actually create one of these save points? It's not just a simple file save. It actually uses this really cool 3-step process that gives developers a ton of control.
These 3 steps happen in 3 different areas, you could say. You've got your working directory, the staging area, and the repository. Let's see how they all work together. So everything starts in your working directory. That's just the folder on your computer where you're actually writing code, making changes, doing your thing. Now, when you're ready to save, you don't just save everything. You first move the specific changes you want to save into something called the staging area. Think of it like a waiting room, or maybe like putting items into your online shopping cart before you check out. You're getting them ready for the final save. Once you've got all your changes ready to go in the staging area, you take the final step. You create what's called a commit. A commit takes everything you staged and creates that permanent snapshot, that checkpoint. And it saves it to the repository, which is basically the official history book for the entire project. So that's how you save your progress. But that's only half the story. The real power of Git, the thing that makes collaboration possible, is a feature called branching. And this is where it starts to feel like you're working in parallel universes.
So, imagine you want to try out some crazy new feature. It's risky. It might not work. The last thing you want to do is mess up the main working version of the project for everyone else, right? So instead, you create a branch. It's like creating an alternate timeline, a totally safe sandbox copy of the project where you can go wild and experiment.
So here's what a normal project looks like. It's just a straight line, one timeline, usually called the main branch. Each of these points is a commit, a checkpoint, building on the one before it. This is your stable, reliable code.
And then this happens. A developer creates a new branch, and you can see it splitting off from the main timeline. Now they have their own parallel timeline. They can add their own commits, commit A, commit B, and it has zero effect on the main branch. Meanwhile, someone else can keep working on the main timeline, adding commit 3. The 2 universes exist side by side, totally independent.
And the beauty of this is you can experiment, you can break things, you can fix them all on your own branch with zero risk. And then, once your new feature is perfect and ready to go, you perform what's called a merge. This magically combines your alternate timeline right back into the main one, bringing your new feature into the official project.
Okay, so let's clear up something that confuses pretty much everyone when they first start. You've heard of Git, and you've probably heard of GitHub. They're related, for sure, but they are not the same thing. Think of it as the tool versus the clubhouse where you use the tool.
So here's the breakdown. Git is the actual software. It's the program on your computer that does all the tracking, the snapshots, the branching. It's your personal time machine. GitHub, on the other hand, is a website. It's a cloud service that's built to host your Git projects. It's the online place where you store a central copy of your project so that your whole team can access it. It's kind of like a social network, but for code.
And super important to know, GitHub is just one company, one brand. There are other popular ones out there, like Bitbucket and GitLab, that do the exact same thing. They all just provide a home on the internet for your Git projects so you can share your code and work together.
So let's wrap this up. At its core, Git is the technology that gives developers superpowers. It gives them those safe checkpoints, the commits, and it gives them those parallel timelines, the branches. It's what makes coding safe, and it's what makes modern teamwork on massive projects even possible.
It's really the invisible engine behind almost every app, website, and operating system you use every single day. It's how these incredible, complex ideas actually become real things, one safe, controlled step at a time. So, now that you know how the time machine works, what are you going to build with it?